Okay, so let's address part one. Why? Why would I build a laser cutting device? So this all started last year when I decided to build the big 3D printer that you can see on screen now. The big 3D printer ended up getting about two-thirds of the way complete is really what I'm trying to say. As in I finished 2 out of the 3 axes and had successful movement on them. I created a modified version of the Marlin firmware, and I had a plan in place as to how to complete the project. The real issue is that the Z-axis is by far the hardest axis due to the mechanical complications of moving a heavy bed, and I was just never able to get a reliable Z-axis working, and at this point I would have had to put in a lot more money to buy better lead screws, better rods or linear bearings of some sort. And I probably would have had to do some metal fabrication for a mounting device. So at this point, that isn't happening. Because I don't want to put any more money into the project when I have a perfectly functional, normal-sized 3D printer, and am not going to be using the extra size regularly, which meant that a laser cutter was a more practical device because I already had almost all of the materials needed to complete this project from various other projects. So basically the concept behind this involves taking one of these laser diodes and mounting it on the chopped off 3D printer. The bottom will be chopped off, and then creating a modified version of Marlin with all of the thermal protections disabled to allow me to use a laser cutter instead of a hot end. I also disabled the Z-axis. Okay, so now comes the hardest part, actually building it. So basically, my plan for this was to take the what was basically going to be the extruder assembly from the chocolate extruder, as well as a laser diode that I already had, and combine them to allow me to easily adjust the focus of the laser. This would then be mounted to the printer to replace the hot end assembly. However, first I had to mount the laser diode to the chocolate extruder assembly, which was actually fairly straightforward. I used 2 3D printed L brackets and M3 screws mounted into the back of the laser, and then welded on to the plastic of the 3D printed plastic of the chocolate extruder using a 3-doodler pen. These are pens like this come in very handy when you want to join plastic parts. They make a very strong bond, even without extruding any other plastic. And if you want to fill gaps, you can extrude extra plastic through them, as I did here. After I had started combining these two parts, the next step was to begin stripping down the 3D printer. Okay, so now we get to the start of breaking down the actual 3D printer. At this point, we have our laser diode mounted to our chocolate extruder assembly, but we don't have a real idea of how we want to mount it yet. I know I need it to go off of these 2 M3 screws that are just slightly off frame right now that are holding on the hot end, but that means I'm going to need some sort of adapter plate to get it there. So once we start disassembling the hot end assembly of our 3D printer, we can take some measurements and design up some mounting hardware in CAD. And spoiler alert here, I did also have to end up doing some very, very simple metal fabrication, basically just drilling a few holes into, cutting and then drilling a few holes into a piece of flat aluminum, because the plastic ended up being too flexible for the relatively heavy laser assembly that I was dealing with. Yeah. Okay, so to actually mount the laser assembly, I designed an M3 slider for flexible positioning, and I grabbed an M3 hex spacer off of Thingiverse. So this is where real progress starts to be made. At this point, we have disassembled the big 3D printer enough to have a separate laser assembly that I've laid down on a MDF bed. We have successfully mounted the laser assembly using an aluminum piece to replace one of the M3 sliders for more firmness. Though this assembly, while it tries to be pretty strong, ends up just being too heavy for the for how this is built. You can see we still have some wiring to do. One of the end switches wires broke, and there's still a decent amount of wiring to do. And right now, our main goal is to load on the firmware, which you can see I'm having some issues with right now. That's Windows 10 being weird with Arduino. The drivers were not installed, even though they had been installed at some point, because Windows 10 is weird. I just had to reboot my computer, and it all ended up working. Though at some point I was trying to do it on a Mac, and that wasn't working either. It just wasn't showing up in on the Mac. Anyways, I could have booted that computer into Linux as well and tried that, but by the time I bothered rebooting that computer, Windows 10 was cooperating. So we loaded onto firmware. I will have the firmware available on GitHub or something. It's pretty standard Marlin. At this point, it's probably quite an out-of-date version, because it's based on the version of Marlin I created last year when I started this 3D printer project. And it just has literally every temperature protection disabled, because we're not dealing with any temperature things, because we're on a laser cutter. So once I got the firmware loaded, I started testing the printer, and that's where I started running into issues. So basically, as you can see here, it was lasering all on top of each other. And sometimes I would even get these weird patterns, which you can't see right now, but should be up in a second. So basically, yeah, there's the weird pattern. So basically what I ended up doing was trying to figure out why it was either lasering on top of each other or doing the weird patterns. So I mounted a pencil and unplugged the laser so I could try to have it move around with that. And I was really just having trouble having it make fine movements. So what I ended up deciding was ultimately the best option was to just give up on the adjustable laser assembly, because it was very heavy, and I had this kind of intuitive inkling that it was probably too heavy for the underbuilt motion assembly of this device, because in an interest of saving money, I made a very basic motion system, and this object was much heavier than it was designed for. Okay, so once we removed that extra assembly, we were able just to mount the laser directly and get our first successful, I guess you would call them prints. The G-code was generated in Inkscape using the JTech Photonics plugin. This plugin is popular with homemade laser cutters because it allows you to put in a laser on and a laser off command. In this case, for laser on, we used M104 S190, and for laser off, we just put M104 because the software automatically adds S0 to the end, even if you put S0 and then you get S0 two times, and then it just gets weird. So our very first print was mirrored, and this is clearly not ideal. But we are able to change the mirroring in Inkscape. So now I just have to remember to do that for things that depend on their orientation. So you can see we are redrawing it here, and this was originally vertical video because we're drawing it vertically, but I just flipped it for you. So you can see it as it actually gets drawn. It's being drawn in reverse. And you can see the mirrored one above it, and it's drawing it right below for real. This is actual speed. The previous video was slowed down for narration purposes. Honestly, this is pretty good. I can do it a lot slower and actually cut through cardboard, which I will show you later. But this is just for engraving, and I can actually go a little bit faster than this. This is, I believe, 50 millimeters a second or whatever. The unit is, it's 50 inputted to the speed value in the JTech plugin. I've had it go up as high as 120. And I still get decent results engraving. Cutting, I went down all the way to 25, and I did 2 passes. And that was for decently thick corrugated cardboard, and that was ever so close, but it didn't go through, so we'll show you that later on what it actually took to get it through. In the meantime, we'll switch to some sped up footage of this finishing. So just note that in real life it took about 4 minutes for it to do this whole engraving. But again, I could probably have it do it at about 2 to 3 times this speed if I really wanted to, and still get quite a good engrave. And as you can see, the result is a success. So at this point we're just about done. The laser assembly is still held onto the base by nothing but the amazing force of gravity, which is not ideal. I will eventually make some brackets. We've installed some lights on the side that you just saw. And here we're burning a grid into the base to help with positioning. So this was a big improvement over just having the laser mounted on something like a 3D printer. The fact that I have a base so I can accurately position my laser. There you can see it turning off as it moves, which confirms that everything is working properly in the slicer. And the LEDs end up getting hooked up to the motor control on the bed. Not the motor control, sorry, the bed control on the control board. That's what I'm trying to say. The hotbed control. So they can be controlled that way. So that is it for this project right now. There will be a part 2 because I'm not yet done. I still want to cut stuff, and I still want to show you how I ended up attaching it to the board, which I don't know yet, and what I ended up doing for power, which I realized I never photographed, and I don't feel like doing that right now. So that will all be part of part 2. Which will basically be results and tuning.